You ever just mind your own business? And you remember that one time that little Jimmy sent you flying while playing rugby in high school? And you just thought to yourself, how did he do it? Well, to explain that, we will first need to learn about one of the most important laws of physics, which is the conservation of momentum. Incredible Science 2020 edition.
Firstly, let's define what momentum is. The governing equation for momentum is P equals mv. We use the letter P to represent momentum because m was taken. The little m represents the mass of an object, which is how heavy it is. V stands for velocity, which is how fast the object moves. The law of conservation of momentum states that momentum is neither gained nor lost, but transferred within a system. To make it easy, let's imagine that friction doesn't exist for now, which would be terrible in the real world, by the way. Let me introduce to you ball A and ball B. To begin with, ball A and ball B are moving towards each other. After the collision, ball A and ball B have lost all momentum and become stationary. This is possible because the system momentum is equal to the momentum of ball A and ball B combined. Because the balls were moving in opposite directions, they will either bounce off each other or cancel each other out. In this case, they cancel each other out, meaning the product of their individual mass and velocity must equate to one another. Due to the law of conservation of momentum, we know that the momentum of the system will not change, so momentum of ball A and B together must be equal to 0 as they act in the opposite direction of one another. Let's put it into a real-life example.
Imagine you're a really overweight snail, you've just had your favourite ginger beer at a restaurant.
Oh no!
And you knock over the bottle. It's on a dead smooth table, you have no idea how you do it. But it's rolling towards the edge with no friction. This bottle, it weighs 1 kilogram and it's going towards the edge at a meter per second. You panic.
Oh no!
It's twice your weight.
Oh no!
How are you going to stop it? You start charging towards it to stop customers' foot from getting crushed and potentially getting a lawsuit. So, you only have a massive 0.5 kilograms? What velocity are you going to need to go? If you answered 2 meters per second, you must have paid attention in high school. However, if you didn't, that's no worries. Let's work through this together. Since a snail is moving against the direction of the ginger bottle, its momentum is opposite to the bottle. For the snail to completely stop the bottle, it needs to travel at a speed that will result in an equal but opposite amount of momentum. So if the bottle is rolling at 1 meters per second and it weighs 1 kilogram, its momentum is equal to 1 kilogram meters per second. For the snail to produce 1 kilogram meters per second of momentum with a mass of 0.5 kilograms, its minimum velocity would be 1 kilogram meters per second divided by 0.5 kilograms, which is 2 meters a second. Therefore, your chunky snail could stop the bottle from hitting the ground, shattering and getting glass in all those customers' feet. Or the snail could end up inside a bottle. Who knows?